We're going to start out this screencast by creating a new project. Again, we're going to use the command line app template. And this one we're going to call namespaces, or actually, let's call it packages example, just to keep it short. Now, this time we need to take note of the package down here. Maybe we should specify a more simple package name. So we're going to call this package 1. And over here, we'll note that we have one package, namely package 1 here. And within that, we have the main class. Now we're going to go ahead and we're going to create a new package immediately. And this package we're going to call package 2. So now we have two packages here. In package 2, what we're going to create is a new class, and we're going to call that class student. Now, we haven't looked into the properties of packages yet, so let's start out by discussing namespaces. The thing about namespaces is that, in fact, in Java, a class name is not just the name that we see up here. We have a term called the fully qualified name for a class. And actually the fully qualified name for this class here is package1.main. In the same sense, down here we have student, but the fully qualified name for this class is package2.student. Now we can show this or demonstrate this by declaring a variable in a bit of a different way than we're used to. So down here we're going to create a variable with type package2.student and then write s1. And we're going to instantiate this by calling a default constructor on student class. Now, of course, we haven't created a constructor down here in student, but there's one thing in Java that when we are creating a new class, we also inherently have a no-arg constructor, a constructor without parameters, which enables us to immediately call constructors on our new class without even specifying one. This one, the no-arg constructor or the no parameter constructor, corresponds to the constructor that we could explicitly define like this. So it's a constructor that seemingly does nothing to the student object that we are creating. All right. So why is this important? Well, the thing is, I could actually, if I wanted to, go ahead up here, create a new Java class, and I could call that student as well. Could just create a no-arg constructor for this one as well, just for the sake of it. And up here in our main class, what I could do is I could choose to create another student object by first declaring package1.student s2 equals package1.student, and then call the constructor on that one. These two objects are different types. We wouldn't see that if we were to remove this in front of the type that we specified for the variables. But as we see, Java has no problem in differentiating between the two because they're in different namespaces. Or said in a different way, they're in different packages. This is a useful property, of course, because this means that if we are importing libraries that we haven't written ourselves, we won't have any collisions with their class naming in as far as we've used different packages than the packages in the library. So that's it for namespaces. Now, there are other things that packages can be useful for. So we're going to go ahead and delete the student class in package 1 as well. Like this. Of course, this one will now yield an error because now this type doesn't exist anymore. We're also going to go ahead just for the readability and remove the package in front of these types here. And then instead what we're going to do is we're going to import the student class in package 2 by adding this statement up here. Now we're able to work with our student type as before. Now we're going to demonstrate access protection. And access protection you can control through the access modifiers. Access modifiers is what we're seeing here in front of our constructor, public, and in front of our class, public as well. But as we know, there are different types of access modifiers. So here we could choose to say that we have a protected attribute, and we could call that name. And down here in student, what we could do is we could add a parameter to the student constructor, and down here then we could say that the value of our attribute name should be equal to the value of our parameter name. Up here, of course, now we are forced to specify a name when calling the constructor because there's no arg constructor in student anymore. So here we're going to call it John Doe. Why not? Now, because I made name down here protected, this means that it's package protected and that I'm not able to access the value of it outside of the package. So if I'm in a class up here in package 1, which is of course a different package from package 2, I'm actually not allowed to say s1.name. It'll even give me an error. And it says name has protected access in student package2.student. So this means I cannot access the attribute this way anymore. One way to fix that, of course, is to go down here and change the protected modifier of our name here to public instead. And if I did that, what we'll see up here in main is that now we don't get an error from this anymore. So I could actually write system.println and go ahead and print out the value of our attribute. So let's go ahead and run this program and see if we indeed get the name of our student out, John Doe. And just for the sake of it, we can go ahead and change this back to protected and see if, in this case, we still get an error. So I won't be able to execute this program without an error. Now, name has protected access in package2.student. So this shows how we can use access modifiers to change the visibility of our attributes. Now, of course, this is not only valid for attributes, it's actually valid for attributes, it's a value for valid for classes as well, it's valid for constructors, and of course it's valid for methods as well. Now, one thing that we should know is that having public attributes is generally not a good idea. We have the concept of encapsulation in object-oriented programming, which means that we should always make our attributes private, and then if we want to provide access to them, what we should do is we should specify that we have a method that we call get, and then the name of our attribute that we want to get the value of, and then we can return a reference to name this way. Now we've explicitly allowed for outside classes and outside objects to access the value of our name attributes if they're using this method down here. So of course, in order to eliminate the error up here, what we need to do is we're going to use getName instead. Now, yeah, we can of course test this and see that indeed this prints out John Doe. Now, just to show the difference between the protected access modifier and the public access modifier, what we could choose to do is we could change this back to protected. And we are going to disregard the discussion of whether this would be a good idea or not. And then, of course, validate then again, this won't work. But if we were to move this class into the same package as main, we'll see that now we're actually allowed to do the direct access on our attribute when it's protected. And then if we were to change this to private, of course, then again, we wouldn't be allowed to do this anymore. So private means that it's the class only. Protected means that it's the class and other classes in the same package. And then public is a class in any package.